Alrighty. It's going on page 145 and we're done. We're still talking about vectors. We are going to revisit bearing. Okay, we talked about bearing once before and how it's a different way to get the angles that we need. So the direction of a vector can also be given as a bearing. And bearings are frequently given in application problems because that's the way they're going to use it for, real world stuff. So there's two different types of bearing. There's quadrant bearing and true bearing. Quadrant bearing is the one that will look like this: south 60 degrees east, north 30 degrees west, something like that. It is measured off of the north-south line, or like your y-axis. So this angle here would be south and then 60 degrees east. Or I could go north and 30 degrees west, something like that. True bearing is the angle measured clockwise from north to the vector. So although this is your quadrant bearing, the true bearing starts with north at 0 and comes around this way. So that would be your 0, unlike the 0 that we are used to. And that would make this 120 degrees. True bearing is always written with 3 digits, so 15 degrees would be 015. Okay, so there's 3 things that we're going to deal with: true bearing, quadrant bearing, and then still theta. Our theta, where 0 starts at 0 on the positive x-axis like we're used to. So with this particular vector, having this south 60 degrees east or 120 degrees of true bearing, the theta, which would start here at 0 and come around to here, what would that measure be? 330. Because you got 90, 180, 270, and then you add another 60, so it would be 330 degrees. So 3 different ways to talk about that angle. We're good? 120, bearing starts with 0 here and goes clockwise. Okay. From 0 right here to the vector. So then this has to be 30 because it's 90. Yeah, okay, does that make sense? Okay, we good? Anything else? All right, so let's look at, it says for each vector, give the quadrant bearing and the true bearing. So on this one, they've given me theta. Theta is 85 degrees. My quadrant bearing is going to be north something east, right? So north, how many degrees east? 5, okay, 5 degrees east. And then my true bearing, which starts with 0 here and goes to the vector, is going to be 5 degrees, right? But it has to be in 3 digits, so it's 0, 0, 5. It's just the way they talk about it so that you always have the 3 digits and you're not confused about anything. It's just the way it is. No. All right, so then we have this one. We want the quadrant bearing first. So this is going to be south something degrees west, right? So south something west. How could I figure out what that something is? Okay. You could, I heard a couple of things. I could take 180 from 212, that gives you this, but then you'd have to subtract that from 90, right? Or this whole thing to here is 270 minus 212, right? What would that give you? 58 degrees. Okay. So there's more than one way to, y'all ever heard the term, there's more than one way to skin a cat? I don't know why that's a thing, but that's a phrase. It means there's more than one way to do things. I know, I don't know why that popped into my head, but that's like one of those old-timey sayings. I don't know why you'd want to skin a cat. That's terrible. Don't ever do that. But there's more than one way to do things. So there's more than one way to get there. Sorry, it's very random. It just like popped in my head. Okay. So then the true bearing, okay, I don't know. If you ever read those books that have like the origins of weird phrases, there's no telling where that came from. All right, so true bearing is going to start here and go this way. It always starts at 0, or it always starts up there at 0. It always goes clockwise, yes. So we just do, 180 plus 58 is going to give us 238 degrees. All right. So you do number 3. So it would be north what? 24 degrees west, right? And then my true bearing would be 336. Good. Start here. Take 360 and subtract 24 because you're almost all the way around. We good? So there's different ways, like it depends on where the angle lands, whether you're just going to be able to take 360 and subtract something or take 270 and add something, like it just depends on where you end up. Just make sure that you can reason around it. Okay, you got to be able to reason around the quadrants, think about where your angles are. Don't even try and do this without drawing it because you're just going to be all kinds of confused. Okay, yes ma'am. Because it always goes from north-south, so it just depends. I'm either here and I go this way, or I'm here and I go that way. It goes either way. Okay, anything else? All right, so one thing I want to point out before we move on. When a degree measure is given without or with no additional directions, it's assumed to be true bearing. So if it says bearing and it gives you an angle, then you don't have to wonder if it's south and east. If it doesn't say it, it doesn't say it, so it has to be true bearing, okay? So it's just, it either has the north and south or whatever, or it doesn't. So let's look at a couple of these short ones first. It says an airplane is flying at a bearing of 245 degrees at 550 miles per hour. So our vectors, the magnitude of our vectors can be a velocity or it can be a force when we're working with these. So it says give the vectors, or give the velocity of the airplane as a vector in component form. And remember, component form is your pointy bracket form. So first we're going to draw a little picture so we can get this in the right spot. Okay, and these are dotted because this is not an X and Y axis. I just need perpendicular so I can get my angles in the right place, but it's not necessarily at 0. That is as a bearing of 245 degrees. So a bearing starts here at 0. This is 90, 180. This is 270, so 245's got to be in here somewhere. And so this is my 245 degrees. And then this is 550 miles per hour. When I do this, when I want to put this in component form, I'm going to use the magnitude times cosine theta, magnitude times sine theta. So I need the magnitude. They gave it to me. It's 550. I need theta. They did not give me theta. They gave me the bearing, which I forgot to write. Oh, goodness gracious. I messed that up. Okay. Whoop, bring that back down. With the bearing, which is beta. True bearing is beta. We talked about that before when we did bearing. Yeah, it was a long time ago. So what this is beta. I want theta. So theta is starting at 0 and coming around this way. So see if you can figure out what theta would be. Somehow, and again, there's different ways to reason through it, so I'm not going to tell you what to do. I want you to come up with it. Then we'll see if we agree, and I can talk you through one way to do it if you need to. All right, so what are we thinking? 205. Good. So Alex, tell me what you did.
I did 245 minus 90.
Okay.
And then 360 minus 155.
Okay. Okay, what did you do then? Did you get 205? Okay. Somebody want to tell me a different way to do it? Go ahead, explain it.
There's the first quadrant is 90. Yeah, there's like that whole thing is 90 right there, which was then out. So taking that away will give you whatever is left. Then you subtract that from 360 to get the other angle.
You see that? It's okay.
Like
it makes sense. He's filling in the blanks. So what he did basically, because I wouldn't have thought to do it that way, but it works. You see, this is where they overlap, right? Right? So you see where they overlap? So he's taking away the 90 that they overlap. So that leaves you with this and this, which would be, together be 360. So if you just take what's left and subtract that from 360, that's why you get that part there. That's not the only way to do it. If that's blowing your mind, don't worry about it. That's why I didn't tell you what to do. Okay? So somebody tell me something different. Huh? Yes, yeah, so that works too. So what she's saying is, instead of doing that, if you basically took 270 minus 245, so you get 25 right here, and then add that to 180, that works too. And if that makes more sense to you, that's fine, because there's not a right and wrong way. You got to be able to reason through it. Oh, because 270 goes from here. This is 90, 180, 270. Like the first three quadrants together this way is 270. Yeah, see, that part doesn't make sense to you. Your way doesn't make sense to her. It's fine. Anybody want to give me a different way? Okay. It's whatever works for you. What would I have done there? I probably would have done what you said. Where like I have this right here, because I can see that this is 180, so I need to know what that is. So I'd subtract it from 270. Yeah. Okay. Are we good? Okay. It's all right. See, that was good. I was thinking outside the box there. All right. So now that we've, yes, he's a genius. All right. So now that we've got that, we want our vector in component form. So our vector is equal to the magnitude, which they gave me, 550, times the cosine of theta. It's very important they're using theta, not just the angle that they gave you, and that's 205. And then it's 550 times the sine of 205. Okay. So since we actually want the actual numbers, we're going to punch that in our calculator. You got to make sure your calculator is in what? Degrees. So make sure it is in degrees. Punch away. Make sure that we agree. Yes, ma'am. Because it is the speed, or our velocity. So your velocity or your force is going to be the magnitude of your vector. That's just like the definition of what happens with the vectors. All right. Questions? Did y'all agree with my numbers? And if you've got your vector correct and your picture correct, this is pointing towards the third quadrant, and so is that vector. Remember, that vector kind of looks like it's in the third quadrant, but it's not anywhere. We don't know the location. Those dotted lines are just to give us a perpendicular, but its direction is towards the third quadrant. Okay? We good? All right. Let's look at the next one. Wait. I'm sorry. Wait. Okay, whoa. Well, because it can be anywhere. The direction is towards the third quadrant. So even if I was to actually graph it somewhere, even if it's like over here, it's still pointing, its direction is pointing towards the third quadrant. It is, well, that's the third quadrant, negative. Okay, it's all right, I know, click, yeah. All right, so that made sense to you, you were just thinking about the numbers weird, okay. All right, so then let's look at number 5. It says, a man pushes a lawnmower, so again, we're gonna need a little perpendicular here. So the man pushes the lawnmower with a force of 25 pounds uphill at an angle of 40 degrees. So if this is like the ground, then he pushes it uphill. This would be his 40 degrees. And his force is 25 pounds, like so. So then what is theta? 40 degrees. We don't have to do anything fancy here. If it started at 0 with the positive x-axis, positive x-axis is not really the x-axis, but that being 0, then that is theta. We don't do anything weird there. Then our vector is 25 times the cosine of 40, 25 times the sine of 40. And then I use the calculator. Am I boring you? Hi. So our vector looks like it's directed towards the first quadrant. That would be positive, and we'd be good there too. No, okay, I'm thinking about that. Like, why would I not do that? Probably, yes. Yes, because that's a good point, yeah. Because you could draw it that way, and you could have it, like I could draw it that, but I could still draw it that way, because I'm just trying to process. That's a good question. And I could make that 40 degrees, right? Like, I see what you're saying. So, then theta would totally change. But, and it would be negative, positive, yeah. It would still not come out right. So, no, but that's a good question. I guess because you assume when he's pushing it forward, he's going in a positive direction. So does that make sense? So you've got to go in a positive direction as far as your x is concerned and your y. Do what? So yeah, this way would be negative. You're pushing backwards. Be very, very talented. But no, that's a good point though. But yeah, we're pushing it in a positive direction. So like if this is going to be our distance, we have a positive distance there. Okay, that makes sense. That's a good question. Right, that's fine. Go ahead. Uh-huh. Yes, but it did not use the words bearing. That's why we use that. That's why I put it there, because it said nothing about bearing. It's just the angle. He pushes it at a 40-degree angle. Does that make sense? So then 0, yes. Yes. That's a good question. What else? All right. So now we have a cruise ship that is sailing at 20 knots in a direction of north 12 degrees west. So north 12 degrees west would be right here. This is 12 degrees, right? And this is 20 knots. That's your velocity. Okay. And it says give the velocity of the cruise ship as a linear combination. So I need theta. What would theta be? 102, because 90 plus that 12 is 102. So that means then that my vector is 20 times the cosine of 102 and 20 times the sine of 102. Well, we're going to do this first. Yeah, I would put it in component form first, because it does say as a linear combination of vectors I and j. I would go ahead and put it in component form and then do that. I just think that's easier. So you get negative 4.158 and 19.563. So then, to get that linear combination of I and j, it would just be negative 4.158I plus 19.563j. And the I and j form, remember, is just a different way to write it, meaning the same thing. You would use that more for when you are working with matrices. It makes more sense three-dimensionally and with matrices, really. But, or when it tells you to, but we're not using matrices right now. All right, what questions do you have? All right, flip it over. You very well may. It depends on what you do. If you're going to be an engineer, you're going to use this a lot in your engineering classes, so yeah. I mean, will every single one of you like be sitting down 20 years from now and working these problems? No, probably not. But will some of you apply this stuff in things you do? Yes. I mean, no, I know. To me, that's a legit question. Like, why the heck do we need to know this? When are we ever going to use it? All right. Now, if two or more forces are acting on an object, then we have what's called resultant force. That is the sum of two vector forces, right? When we draw the pictures, there are different ways you can draw these. You can draw the vectors kind of together, or you can draw them where it makes more sense as far as the application itself. And I'll kind of do a little bit different ways on different ones. But this says two tugboats are pushing a barge. If tugboat A is traveling in the direction of south 80 degrees east, tugboat B is traveling in the direction of north 65 degrees east. Both boats are pushing with a force of 400 pounds. Okay, so I'm going to do tugboat A first. So tugboat A says we're going south 80 degrees east. Looks like this. So this is 80 degrees, right? And they both have a magnitude of 400. And then I'm going to make another little cross here because, again, it's not the x and y axis. I'm just getting a perpendicular wherever I am. Now, do I know exactly where these are starting? No, but this is just going to give me an idea of what's happening. Then this other one's going to go north 65 degrees east, and it has the same magnitude, so they really should be the same length, you know, basically. And it doesn't matter. I mean, you don't have to do them perfect. I am going to redraw something in a minute where it would be better if I was a little bit more accurate. But so this is what's happening. So we can think about, you know, the ship itself is right here, that it's being pushed, and it's being pushed like that. Okay. And so this is A, this is B, right? So theta for A, what would theta be for A? 350, right? Because here we got 90, 180, 270, and then 80 more. So it's going to be 350 degrees, right? Or you could think, I've got 10 more to get to 360, so it's got to be 350. That's another way to look at it. Whatever. All right, and then what would my theta for B be? 25. Okay. Any question about either angle? Because this is 65, and to get 90, it's the other part of 90. Okay, good. Everybody good so far? All right. So now we're going to, I'm going to redraw it over here because I want to see if I can draw it accurately enough that it might actually make sense to you. We'll see. But if I have, so if I'm going to redraw vector A, it looks something like that. And this is, oh wait, I don't need to measure it. Or then 65 degrees is going to come out about like that. They should be about the same length, so we're going to pretend, right? And then, so those are the two vectors, because when you actually add them, you don't put them arrow to arrow, right? You start the next one where the last one ended. So the resultant vector would look something like that. When I add them, I'm getting that pink vector to get my resultant vector. Does that make sense to you? So when they're pushing on the ship at the forces they are, it's going to make the ship go that way a little bit, which looks like it's probably aiming towards the first quadrant a little bit, not a huge angle as far as theta is concerned. All right, so let's find our two vectors. We've got vector A, which would be 400 times the cosine of 350, and then 400 times the sine of 350. Then vector B is going to be 400 times the cosine of 25, and 400 times the sine of 25. Okay, and I'm not worried about punching anything in the calculator just yet. So those are the two separate vectors, like the two green ones that I drew over to the right. What I want is the resultant vector, or the pink one. So when I add two vectors, that picture is me adding them geometrically, like literally snapping them together. Doing it algebraically, you add these two values, add these two values. So what we're going to do that in the calculator and kind of do it all at once here. So to get that resultant vector in your calculator, you want to make sure it's in degrees. You're going to add 400 cosine 350, close parentheses, plus 400 cosine 25. Get your answer. Then store it. I highly suggest on these to store them in X and Y. Okay, so get your first answer, shift store X, and then your second one, shift store Y. Very important that they're stored. Okay. Let me know if you're having calculator issues and that you're getting those. Are you in degrees? Okay, make sure you're in degrees. And remember, when we recall these, these are not like the TI calculators. You don't hit alpha. You just do recall X, recall Y when you need them. So all we have found at this point is the resultant vector, and that's not what they asked us for. They asked us for the magnitude and direction of the resultant force. So now that I have that resultant vector, everybody with me and have that? Okay. Now I need to find the magnitude. So the magnitude of A plus B is equal to the square root of x squared plus y squared, right? And in your calculator, you literally do that. Like, you still have to write it down. That's your process. But you have stored them in X and Y. So you put that exact thing into your calculator. Square root, recall X squared plus recall Y squared. You should get your answer. Make sure that your number agrees with mine. And let me know if it doesn't and you don't know why. What would the label be on this? Pounds, because that's how much the force is. The force is in pounds, and this is your magnitude, so this is pounds. Okay. So now I need the direction, so that's theta. I find theta by doing what? Tangent inverse of y over x. And so again, you literally put that in your calculator. Tangent inverse of y over x. You get 7.5. Now, here's what you have to remember, is that you have to pay attention to your quadrants. So first of all, my resultant vector here, this vector, that is aiming towards the first quadrant, right? Because it's positive, positive, which is kind of what my pink one looked like, but my picture wasn't super accurate, but it works. So this is a first quadrant angle. That's good. But it says in direction as a quadrant bearing. So if I have this here, and this is my 7.5 degrees, what I need is my answer to be north something degrees east, right? So I really need this measurement here. It would be 82.5. Good. So on the angles, you have to pay attention to a few things. What quadrant are you in? So am I in the correct quadrant? And then am I giving it in the correct form? Because they don't always just want theta. But theta is what the calculator is going to give you. That's what we work in mathematically. What questions do you have? Say that one more time. No, this is the component form. So like this is the vector, but this is the magnitude of the vector, and then this is the direction of the vector. Yes? Well, this gives you magnitude and direction. Like I'd know that I'm going to go out a lot farther than I am going to go up when I do my vector. Like I'd go out 700 something, but only go up like 99. So that's what this makes it. But to find out how long it is really and what this angle is, or what the angle is coming this way, that's what these two things are. This is like the polar version, and this is like the rectangular version. Does that help? Okay. I'm trying to think of another way to say it. I made it worse. Shut up. We'll come back to that. All right, so two forces with magnitude of 85. I've already gone over that. Two forces with magnitudes of 85 pounds and 120 pounds are acting on an object at angles of 35 degrees and 140 respectively. All right, so up there I drew them where they were touching, and so you could see the triangle. You don't have to do that every time. If you can just get them drawn so you can think through the angles, they don't have to always look like that. So I'm going to do this a little bit differently. You can do them however you want. I don't care. But if I have a magnitude of 85 degrees, that's with my 35 degree angle, right? So a 35 degree angle, and notice it just says an angle. There's no words of bearing, nothing. So that means it's just theta. So this is 35 degrees right here, and that's 85 pounds. And then the other one is 120 pounds and angle of 140. So from here to here is 140, and this is 120 pounds. If I was going to actually add them, this is not where I would add them. I'd have to like slide this up here and snap them together, but you don't have to draw it that way. You just have to know that you just have these pieces here that you're trying to put together. So for the first vector, so the first one with the 85 and the 35, theta is 35. So it's going to be 85 times the cosine of 35 and 85 times the sine of 35. Then for my second vector, it's going to be 120 times the cosine of 140 and 120 times the cosine of 140. Cosine, sine, dang it. Did that last period too. What the heck? I'm just writing the same thing twice. At least y'all are paying attention. Sine 140. There we go. So then vector 1 plus vector 2. And that's when you go to the calculator and make sure that you are storing them. If you're having trouble getting the same numbers that I have or storing them, please say something and don't just sit there and be lost and confused. And I'll go ahead and put those numbers up here, but you got to make sure you have them and have them stored. And then I'll let you work on the other parts of that. So make sure you agree with that component form and then find the magnitude and the angle. And we'll talk about the angle too. If you're not sure what to do, at least get theta from your calculator and get that bar, and then we'll talk about the rest. Yeah, go ahead and just like do it, finish as much as you can. But if you get stuck on something, just do whatever you can, and then I'll help you through the rest of it. Okay, are we all at least this far? Mm-hmm. All right, so we got that negative 79 degrees. So a couple of things here. This, when I look at my resultant vector, that vector is directed towards which quadrant? Second quadrant, right? So we need it to be a second quadrant angle. And it says direction to the positive x-axis. So that means it's just theta, right? Well, this angle that the calculator gave me, that negative 80 degrees, is in quadrant 4. I want it to be in quadrant 2. So what do? Add 180. And since all I want is theta, once I add 180, I'm done. And theta is 100.044 degrees. So theta is going to take some, or your angle answer is going to take some reasoning every single time. Okay, it may be what the calculator gave you. I'm not saying that it won't be, but you still need to think through it as you get it. Okay. What questions do you have? All right, we're not going to work all of number 9, but we are going to draw the picture and talk about the angles at least. Once you get that far, I think you can type everything in. So this one says 2 cranes are lifting a statue. Crane A is pulling with a force of 600 pounds at an angle of 35 degrees to the left of the statue. So already that's weird. That's not theta. That's not a bearing. That's just some random angle they decided was with the statue, right? So you gotta, it doesn't really matter where you put the statue, because it could be laying down, whatever. But it probably is easiest just to think of the statue being vertical. But you should get the same thing no matter how you do it. But so I have got 35 degrees to the left of the statue. So this is my 35 degrees to the left of the statue. And that's a force of 600 pounds. And that's crane A. Okay. Then crane B is pulling with a force of 750 pounds at an angle of 50 degrees to the right of the statue. So 50 degrees to the right of the statue, that's 750. Well, not degrees there, sorry. And this is 50 degrees. And this is crane B. All right, any questions about the picture? So then tell me, let's talk about theta for A and theta for B. What would theta be for A? 125, because I'd take that 90 plus 35. Good. And then what about for B? 40. Good. Any questions about either one of those? Once you've got that, the work is like very monotonous. It's the same sort of thing every time, but we good? All right, grab your next piece of paper. This is going on 146. All right, so we have an airplane that's traveling at a speed of 500 miles per hour at a bearing of 325. So this is another one where I'm going to draw it, like actually put end to end so that you can see what's really happening with the airplane here. So I have this airplane. Here's my little perpendicular. And it's traveling at a speed of 500 miles per hour, bearing of 325. So it's going to start here. This is 0, 90, 180, 270. So 325 is up here somewhere. And that is, so this angle here is 325. And this is 500. What are we confused about? Okay. All right. So then I'm going to draw another little perpendicular. Instead of drawing them both off of this one, which I could, what's really happening when you add them is the next one would start here. So I'm going to put the little perpendicular here so I can get my angles accurate. And then it says once the airplane reaches a certain point, it encounters a wind velocity of 60 miles per hour in the direction of north 75 degrees west. So it's going to look like this, but not that long. Sorry. I'm trying to make this one a little bit more accurate too so it can make some sense. And this is 75. So we'd had force being our magnitude, but now the velocity is our magnitude, okay? And this is 60 right here. So when you add these two together, you get this resultant vector right here. So that pink vector is what the plane is trying to do. This is the direction he's flying, but the wind is pushing him to the actual course, which is the orange one. So it's like the pink one is your heading, the orange one is the actual course because the wind's pushing you off course. Kind of like if you're trying to paddle down a river that has a current, you might be trying to get to the other side of the lake, but it's pushing you this way so you don't get directly to the other side where you were trying to go. Or when you're at the beach and you look up and you know your towel's like 10 miles down that way because you weren't paying attention because it was carrying you, so it's pushing you. So we have the pink and the purple information. We are looking for the orange, okay? So let's look at this. We've got the airplane. So I need the plane's theta and I need the wind's theta. So for the plane, where this is 325, I want you to see if you can come up with theta. I'll give you a second to think about that one. It's 125. Because you have 35 degrees more to get here, right? So 35 and that 90 is going to give 125. Okay. And then what about for the wind? 165, because this is 75, this is 90, so it's 165. Questions about that information? All right, so let's find our vectors. For the plane, the vector is 500, because that's our velocity, times the cosine of 125, and then 500 times the sine of 125. For the wind, it is 60 times the cosine of 165, and 60 times the sine of 165. Then I find the plane plus the wind, and store that in my calculator. I'm going to pass this out while you're working so I don't rush you. I know I have a tendency to rush you. That's what the calculator gives you. So see if you can figure out what to do with that to get what it's actually asking you for. And I'll talk you through it, but there were three. I'll get you there. Asking me for true bearing, right? It gives me, so before I worry about that though, it gives me a negative angle that would be in the fourth quadrant, right? What quadrant is my vector directed towards? Second. So for me, I would prefer to get my theta right before I worry about anything else, otherwise I'll just get confused with it. So to get the theta in the correct quadrant, what would I do with this number? Add 180. So that's going to give you a positive 129 something, right? So I can add, so this is what it gave me, but I want this, right? So this is my 129. What we want is true bearing. So I need to end up here, but I have to start here and go around this way, right? So I want you to think about this. This is your negative 50, right? Yes, this right here? Wouldn't this have to be the positive 50 because aren't those vertical angles? So see how you could take 270 and add that 50 to it? Does that make sense? Well, I mean, I'm saying 50, but it's like 50 point, yeah, whatever. Okay. Do what? What'd you say? Oh, you said what? So do you understand how, well, and that's one way to do it. You can do it different ways. I'm not saying that you have to specifically do it that way, but you got to come up with the number that is, was it 3 something, 3, I'm upside down, 320.959? That is your beta. It's asking you for the bearing. Bearing starts at 0 and goes around this way to here. Yeah, so 90, 90, 90, that's 270 plus that 50 right there. Okay, I will re-explain this starting tomorrow. Tomorrow we're going to finish these notes because there's little things that happen differently, then you'll have some time to work. Okay? Have a great day.